Okay, okay. Good morning, everybody, and we're going to complete our class today on a discussion of human evolution. And before we start, what are the things that actually distinguish us as humans? If a scientist was to come on from outer space, how would they look at us and see what characters distinguished us from all of the other apes that we are so closely related to? So the first thing is we're the only apes that walk upright. We have permanently have upright posture. We walk on two legs. There's bipedal locomotion. We have much larger brains than all of the other apes. And we have extensive capability for language. It's not to say that the other apes don't have some form of language. They may well do so, but we have extensive language and which embodies symbolic thought and in which we can express abstract ideas. We also, the one thing which really distinguishes us from all of the other apes is that we are the only apes which have artistic expression. And in addition, we are able to plan to make and then manufacture complex tools. Now, morphologically, quite apart from all of the morphological changes that have come with upright posture, there is another trend which we see, especially as we look through the fossil record, and that is that there have been tremendous changes to the face. And in one of the things that we'll see as we look through the fossil record of our previous animals which were very close to human beings, we see that we have a reduced jawbone. It's not heavy, robust jawbone. And also our teeth have been reduced, and the differentiation in our teeth has been reduced. Along with that, we have weaker jaw muscles than many of the others. That is probably a reflection both of our tool usage, which allowed us to prepare food, and also to a certain extent the use of fire, those sorts of cultural things. So the study of human origins is the study of paleoanthropology. And all of our relatives, all of those animals in the fossil record, for example, that are closely related to humans, more closely related to us than they are to the other apes, we refer to as hominins. You'll see them still sometimes referred to as hominids, and you may, I still make the slip. The proper name now is hominin. And we must realize that the hominins share a common ancestor, and they share a common ancestor. We share a common ancestor between the hominins and the apes as well. So there's a common ancestor between all the other apes and the hominins, which proceeded along a separate line. And then all of the hominins share a common ancestor somewhere in the past. We realize that there were many hominins. There were many different kinds. We have found about 20 different species of extinct hominin fairly closely related to us. So we just realize there's not a single line of descent. It's not an easy, neat story to tell. Well, here's the ancestor, and here's the subsequent, here's the subsequent, here's the subsequent. Instead, there's a whole cloud of related species, and we have to look at the morphology and everything and behavior in that cloud to try and follow a story, a trend of evolution from more primitive up to the present day. So here, before we even start, here are some things which people commonly say about the story of human evolution. For example, people will say, oh yes, theorists say that the early hominins were chimpanzees or monkeys, right? We came from monkeys, or evolutionists say we came from monkeys. No. Hominins, the whole group that led to humans, share a common ancestor with the other primates. So that is a very, very clear distinction. The second distinction is one I have made several times. That is, people will talk as if we were looking for a single story, a single line, a ladder leading from early apes up to man, as if there was some sort of ascent. That is not how it works. That cloud of hominins, of related species, many of them existed at the same time as one another. The thing is that we are the only hominin who currently survives. In previous times, several hominins would exist at the same time. We may find their fossils, but and try to put a story together by looking at their morphologies. But it's not to say this one led to this one, and this one led to that one, and that one led to that one. We cannot do that. Just remember that there have been at least, we have fossils of 20 hominins at least, but there are probably many more. Very few of them were ever fossilized. We're very lucky if we ever find fossil hominins. This is a very rare occurrence. So let's just have a look. This is just this is an evolutionary tree, and what it shows us is our hypothesis about where the ancestors lay, and what we're particularly interested in. Let's have a look. The anthropoids, those are all the true primates there, this whole group here, with a common ancestor all the way back here, about 35 million years ago. We're particularly interested in these great apes, the hominoids. Don't confuse that with hominin. The hominoids are the great apes, and we all share a common ancestor about 15 million years ago. Our very, very close relatives are the chimpanzees, and here's our common ancestor. About 6 million years ago, 5 to 6 million years ago, we shared a common ancestor. And that common ancestor gave rise to these lines, the chimpanzee line and then the human line, the hominins. This would be the hominin line here. Currently, we are the only surviving members. So have a look here, and this immediately become, you'll see how confused the story really is. So these are representatives of the fossils, the fossil hominins, and these are almost all from Africa. It's only later on in human evolution that we begin to see fossils in Europe and Asia, and for a reason that you'll see in a minute. But our origins are solidly African. And most of the fossils that we have are from East Africa. And then from South Africa, and Africa south of the Sahara. You'll see that there's, just looking through here, there is a certain trend, but it also gives you the idea what I meant by saying there's a cloud of ancestry. There are many, many related species. We can't see a single line of ascent from original up to man, up to Homo sapiens. But here is Homo sapiens up here. And the first thing that should strike you is how very recent we are. Only with about 200,000 years old is our species, preceding us many, many other related hominins. So when we look, let's just have a look again, we'll go back to that diagram now, but we're going to see, for example, that many of the trends that we see in the skull. There are many aspects of this whole skeleton that we could follow, especially those related to upright walking and to tool use, tool making. But many of the characters that we follow are in the skull and in the face. And that's for two reasons. First of all, a lot of changes occurred in the skull and the face. But second of all, because that is often what we have. That is what is often preserved better than other parts of the bodies. And if we just have a look, at the overall trends, well, there are a couple of things that we can see. First of all, have a look down here at these, and you'll see how the face actually protrudes out forwards. That is called prognathicity. These skulls are prognathous. They have the face pointing out. Have a look up here. Sorry. Have a look up here, and you see how that tendency is lost, right? The next things we'll do together. First of all, you see here, there's no nasal bridge. You see that, how that forms there. And have a look at us with this very distinctive nasal bridge there. The next thing is the jaws themselves and the teeth become more and more refined as we proceed through this whole story. The tendency to walk upright is a couple of the things that are actually reflected in the skull as well. And the main thing is, if you were to look at an early skeleton like this animal did sometimes walk upright, but in common with the chimps, the spine is attached at the back here. You can imagine an animal standing like this. The spine would be attached there at the back of the skull. Come to us, walk upright the whole time, and the spine is attached right underneath here, in the center underneath. So that we will trace that as we go through as well. And the next thing is not reflected in these here, because we don't have the lower jaws here. But a very, very human Homo sapiens kind of trait is the development of a chin. And that's that's a very late development. Apart from that, the one major trend that we see is an increase in brain size. The earliest fossils that we see, the early animals, they have a brain size which is very close to that of the chimpanzees. And that remains the case for many millions of years. Only much later on, and quite suddenly, that the brain size suddenly begins to increase. And we have a very large brain capacity, but surprisingly enough, as you'll hear, we don't have the largest brain of all of the hominins. But here, have a look here. These are early fossils. And this is going to be the first of the trends that we're going to follow. This one here is called Sahalanthropus there, and it's going to be the earliest one. And then with the ones that we're going to be next ones that we're going to be really interested in are these, Australopithecus. And if we look at the brain size here, there's almost no change in the brain size. But look at how long they span for, that is 3 million years. Remember what I told you, humans have only been around for 200,000. We're a blip in the evolutionary scale. Between here and here, there are like 3 million years, and yet there's hardly any increase in the brain size. What does change between this Sahalanthropus and Australopithecus is we see that the spine comes underneath here and suggests that this animal here walked upright more than this one here. Okay. All related, we can see a tendency now for upright walking, which is shown by Australopithecus. So here's the first little one. This was a small primate called Sahalanthropus. And we do think that Sahalanthropus spent some time walking upright, but was probably arboreal. It was probably a tree dweller that occasionally walked upright. Probably walked upright a little bit more than chimpanzees, but otherwise it is rather similar to the chimpanzees. Small brain case. Here, look how the whole face pokes forward like this. It's prognathous. Heavy brow ridge across the top here, which is also a primitive character. And then big, heavy teeth And the teeth are differentiated. The males would have had big canines. There is an intermediary kind of form called Artepithecus between Sahalanthropus and the Australopithecus, called Artepithecus. And we're very interested in Artepithecus for one reason only: we have a very complete skeleton. And it shows that this animal actually could walk upright. And it may have done so on an almost permanent basis, but its upright gait was very inefficient, which makes us think that it must have spent time on all fours as well, and being arboreal as well. But if we look at its skeleton, it's beginning to look very much like an upright walker. We can see that through the structure of the pelvis and of these bones here. But just have a look down here and look at its foot. And can you see how that big toe is sticking out there like that? That's because the foot was placed like that, with the big toe balancing the body. That's a very, very awkward kind of stance. It was also very small-brained. Here it is here. You'll see here that it had these splayed feet. But when we look at the pelvis here, we can see the pelvis is actually adapted for upright walking, but that upright walking very inefficient. And we think that it spent time in trees as well, and probably on all fours, maybe knuckle walking, but it could walk upright. So that's Artepithecus here. We're going to move to our next one, which is Australopithecus. And this is a huge, very, very important, extremely successful group of hominins. They occupied a very wide distribution in Africa. And we know that they were very diverse. There were many different species. We have the fossils of several of the different species. And they lived between 2 and 4 million years ago. We think that they are extremely important for one very good reason. And that is that it is obvious that some of them actually walked upright, and that their upright gait was almost permanent. They may have spent some time in the trees. We don't know that. But all of their anatomy says that they were fully adapted for upright walking. And they began to walk on all fours. They could walk for a long distance on all fours. And just have a look here. Where is my, oh yes, here we are. Here's the Australopithecus here. You can see the species existed for a long time, but I do want to point out all of these here are all related species. These are all related species here. So the brain size, there's been very little change in the brain size. What we are watching as this time passes here is this adoption of permanent upright walking. And then after that, we begin to follow an increase in the brain size. Here is Australopithecus, not a lot different to the chimpanzee, but we begin to follow now through the different hominins that we see. We begin to see increase in brain size. You can see it here. And until we get up to our brain size here, about 1,300 to 1,600 cubic centimeters. But don't get chuffed about that, because in fact, Neanderthal man had a brain size which was equal to or greater than the human mean. So that should put us in our places. Okay, so here we begin to see the increase in the brain size, and we're particularly interested in this line here, there. This one here, this belongs to an organism called Homo Habilis. Now, Homo Habilis is extremely similar in many ways to Australopithecus. And it probably arose from very recent common ancestry to the Australopithecines. Its brain was slightly larger, not very, very, very much larger, but slightly larger. This is Australopithecus afarensis, the Australopithecus that we saw before. It was the species overall was very, very long, lived about 500,000 years. You may have heard of the most famous fossil of all, and that is the fossil skeleton of Lucy. And she was an Australopithecine. And here you can see, here she is here. That's a chimpanzee there. This is the Australopithecine, the Australopithecine skeleton here. And we know just by looking at the pelvis and the thigh bones that this was almost permanently upright. They may well have been able to climb, and they may well have climbed as well, but on the ground they could walk upright and they could walk efficiently for very long distances. And if you look at their stance, we don't have the feet, unfortunately, for Lucy, but we do have very strong evidence that they walked on feet which looked very much like ours, and that is because we actually have footprints. These are footprints made by an adult Australopithecine, Australopithecus afarensis, a Lucy-like animal, and they've walked here across volcanic ash. Remember that these are millions of years old, these footprints. They walked across volcanic ash, and shortly after they'd walked, there was a rainstorm or something which set it like concrete and preserved these footprints. What is interesting is if you look at the footprints, you see the feet here. They walk just like us, with one foot going in front of the other, like that. And there's no splaying of the feet to keep them steady like the earlier ones. Instead, the feet are directly ahead like that. And very interestingly, here is a juvenile. And we can tell by the way that they synchronize that they're probably walking hand in hand, which is rather sweet. So those are actual footprints of Australopithecus afarensis. Very, very important fossil finding. So here is the Australopithecus here. It says here the big toe splayed, but the splaying of the big toe was really minimal. I don't agree with that. But the rest of the skeleton here, especially in the pelvis, these were upright walkers, but with a very small brain, no bigger than a chimpanzee. Here you can see, here's the Australopithecus skull here. Look at its heavy brow ridge, prognathous. It had big differentiated teeth, not as big as the chimps, but still, compared to us, much bigger and more differentiated. Brain size, about the same as the chimpanzee. Very little difference. Here's a human. So we now we know that the Australopithecus afarensis used simple tools. That is, they could pick up things, pick up rocks, and use them. And one of the major uses appears to be to smash open bone. The bone marrow is still in all of the animal kingdom, a highly prized item, very, very rich in fats, and extremely nutritious. And very often we'd find these tools at the site of a kill. We have bones which we know have been smashed open and lying near them at fossil sites. We have the very tools that we use to smash them open. But there now appears another hominin, which is actually able apparently to plan tool usage. And this is such a big change that we give the animals associated with this, with planned tool usage, for the first time we ascribe the genus name Homo, man. And although the skull looks very like Australopithecus, brain is a little bit larger, but not spectacularly larger. It is larger than Australopithecus, but much smaller than human. Nonetheless, Homo habilis is evidently able to make tools which are refined, and they are refined for a purpose. That's really important, because it means that Homo, this animal, actually planned the tool. They had a future use. They didn't just reach out and grab a rock and use it. They took a rock, they changed it, they made it into a tool which they would use in the future. They probably kept them with them. So here he is here, and we call this Homo habilis, or handy man in actual fact. Handy man is the name, what the Latin name means. Associated with, there are a couple of others that are rather similar. We start to see now a slight trend as the brain size begins to increase. So, and what we're going to, here's Australopithecus. Again, I don't particularly like these diagrams that show one leading to another. Remember that this one shared a common ancestor with that one shared a common ancestor with that. That's a better way to think of it. But here is Homo habilis, fully upright, slightly larger brain than Australopithecus, but with this very distinguishing feature that they could make very refined tools. And this Homo habilis, around about between 2.4 and 1.6 million years ago. And they had a hand, they were smaller than us. But when you look at their hand is almost identical to a human hand, almost identical. If you want an idea of the difference between an ape hand and a human hand, what you should do is just cup your tops of your fingers like that, and try and make a precision movement to your curled fingers. And that'll give you a feeling for what the ape hand feels like. They can oppose, but it's difficult to make a precision grip between the thumb and the fingers. Go to the human hand, and we have this very refined ability to put precision movements between fingers and thumb and use the whole hand. The hand usage is completely different. This is one of the major things that we see in Homo habilis, that this idea of tool usage. Remember, the tool usage doesn't suddenly appear. There were probably preceding ancestors, and this was modified by evolution before we actually see the fossil in front of us. But the hand now is almost completely human hand. The brain is not that much bigger. It's a little bit bigger than Australopithecus, but they are able. They lived in groups. We know that, and they probably, had extensive cooperation for hunting and everything. Here are their tools. There's nothing accidental about this. They are creatively created. There is a certain aesthetic to these tools. It is evident that I would venture to say they took pleasure in making a good tool, which is a form of artistic expression. That is something which is really, really human. They really do deserve the genus name Homo. So this is Homo habilis. These are some of their tools. Okay, there he is there. Now we're going to from now on, this tool usage, tool planning, tool usage, it seems to be associated with now a trend of increasing brain size. And the very next one that we want to have a look at is this here. This is Homo Ergaster. Now, it's something to point out here. Don't look at the position of the skulls on this graph. Look at these bars here. This is the time that these animals existed, okay? And you'll see something that, in fact, this Homo Ergaster, which means dawn man, that whole species arose while Homo habilis was still living, while it was still extant as a species. There is some common ancestry here, but they coexisted for a certain length of time together with some others that we won't talk about. This is Homo Ergaster. And about 2 million years ago, that's its first appearance. And Homo Ergaster is really important because it has such a significantly larger brain, smaller than ours, but still a large brain and a couple of other tendencies. In all of the Australopithecines, and also we believe in Homo habilis, there is a considerable sexual dimorphism. There was a big difference between male and female. This begins to disappear. There's just, for instance, the teeth, there's little difference in the teeth size and the size of the canines, especially between males and females. In the Australopithecines and all the way back to the more primitive, the males tend to have big canines. That becomes lost. So we're starting now to look at things which begin to look more and more like us. More and more like us. Here is Homo Ergaster. This a very beautiful, almost complete skull. And just have a look at the skull and you'll realize it still preserves some primitive features. This heavy brow ridge there. It has just beginning to develop the nasal bridge. Still prognathous, still sticks out, but not as much as Australopithecus. There's no chin, but the jaw is still heavy, but not nearly as heavy, and the teeth not nearly as robust as in the Australopithecines. But the one thing which is really remarkable is that it has a large brain. Not as large as ours, but much larger even than Homo habilis. And had we seen Homo Ergaster, we would have looked twice because it looks so human. We would have looked and realized, oh no, wait a minute, that is another species, but nonetheless is obviously very closely related. This is truly is dawn man, because this is the earliest fossil that we have of the large-brained members of the genus Homo. Now, also arising out of that cloud of members of the genus Homo, there is this one, Homo erectus. And Homo erectus is the most successful of all of the members of the genus Homo. I'll just flick back here. Here he is here. You'll see it coexists. Homo erectus coexists with Homo habilis and Homo Ergaster. They share a common ancestry here, but this is a very, very successful line of human evolution. Homo erectus was one of the longest living species. I mean, the species existed, not individuals. They didn't live very long. But the species existed for a very, very long time. And that is because Homo erectus was really one of our most successful members of the genus, apart from Homo sapiens, which is us. So, like, sorry. So, Homo erectus was the very first hominin, the very first member of our group to leave Africa. It was, and that was probably a mark of its success. It probably was so successful it began to compete with itself in Africa, and they began to move out of Africa to escape that competition. What is really important to realize is, as I pointed out, these species coexisted. The Homo erectus coexisted at one time with Homogasta, even with Homo Habilis. And it also coexisted with other species which are much closer to modern man. By far the most successful of all of the species of Homo. The skull looks fairly primitive. It has a heavy brow ridge. It does have something of a nasal bridge, but not as large as it would be. The teeth are reduced. The brain is large, though not as large as ours. But we know many things about Homo erectus because they have actually left behind some very important signs about the way that they lived. There was a famous anthropologist, Margaret Mead, who was asked what did she consider to be the first signs of civilization. And everybody expected her to say something, well, like, oh, when human beings became agriculturalists or something like that. And she correctly answered that true civilization arises when a species begins to care for the weakest amongst it. Amongst the Homo erectus fossils, we have, for example, the fossil of a boy who is about 15 or 16 years old, who was severely cerebral palsied. That is, he was born severely disabled. And that is reflected in his skeleton. It is obvious this child was practically incapable of physically caring for himself, and yet he lived to be 16, 17 years old. That means he was cared for. He was cared for by others. And that is the true symbol of a civilization. In addition, Homo erectus, we know that we have fossils of very elderly Homo erectus who have entirely lost their teeth and would have been incapable of chewing food, for example. And yet they survived to an old age. Somebody was caring for them, probably chewing their food for them and feeding them, or mashing the food up and feeding them. So Homo erectus is not a brute. Homo erectus has very refined sensibilities. The other really important thing about Homo erectus, apart from the fact they made very beautiful tools and all sorts of things, they were the first to use fire. They used fire for three things. First of all, for warmth, which is one of the things which allowed them to migrate, for example, into cold climates. The second thing was they used fire probably as a form of defense for warmth and for social gathering probably took place around a fire. Fire was extremely useful and it had a huge cultural impact. And in looking through the fossil record, Homo erectus are the first group which we see actually use fire. So here is something else about them. We have many beautiful stone tools created by Homo erectus, but have a look here. Look at this hand axe here, and look right here in the middle. That's a fossil. That's a fossil embedded in this rock. And whoever made this hand axe, very carefully made the hand axe around that, exposed that fossil, and then made the hand axe, shaped it around that fossil. That shows extreme skill and an artistic sensibility. Okay. There is an aesthetic quality to these tools which far exceeds that of Homo Habilis. This is a remarkable statement about whoever made this hand axe. So we can't think of Homo erectus, erect man. There had been others which were erect, but when he was named, they didn't know that. We cannot think of them as being primitive. They were not primitive. They were actually quite an advanced civilization and phenomenally successful. We infer also from the way in which they were able to spread and migrate that they were probably wearing clothes as well. They were probably clothed because they moved into cold climates once they had left Africa. They moved very, Homo erectus spread enormously widely. They're found, skeletons have been found in all of these red dots here. We've found fossils of all of those, but there are signs of them, tools, much wider spread even than that. We find Homo erectus tools many places, for instance, in Britain, where no skeleton has been found. But you can see they spread all the way over, almost to Australia from Africa. And that is also a reflection of the enormous length of time that this species existed. So now, as we've looked at Homo erectus and its related species, what we see, first of all, Homo erectus, here it is here, and here as well. And what we see, they have a very large brain, but we now begin to follow this refinement of the face and of the facial features. And here is Homo sapiens here. There's another, but this here is also Homo sapiens. But what we see particularly in Homo sapiens is this very pronounced nasal bridge. Can you see there? That is absent in, this is Homo Ogasta. It's absent in Homo erectus. And it is present here in Homo Neanderthalensis as well. So we're now going to be watching more subtle changes. The skull and the jaw now begin to refine. But what we also follow now, very importantly, are these cultural developments. Because we'll begin to see now that we see more and more signs of the culture that these organisms lived under. Now, one of our closest relatives is this other genus, other species of the genus Homo Neanderthalensis. And Homo Neanderthalensis, also a very successful group. Most of the fossils that we have are from Europe, but there are some from Africa as well, and also from the Near East. They were, in some ways, when you look at the skulls, they look a little bit primitive because they are very heavy. The skulls are very heavy. They have big brow ridge, but they had a very, very large brain. In fact, larger than many human brains. They made very sophisticated tools. They almost certainly clothed because they penetrated right up to very cold climates and survived for a long time during an ice age. They had a really robust, complex culture. And we know that because Neanderthal man actually buried their dead. They put their dead in a grave, usually folded into fetal shape, like with arms and legs tucked up like this. And they put flowers and offerings in the grave with the dead. So just think about this for a minute. Why bury your dead? Why not just eat them? Why take the dead body and not just discard it or move away from where it is, which is what many animal species will do. They will simply discard dead members of their species, leave them for the scavengers. Here, Neanderthal man took the dead and actually buried them. That implies that they still attach importance to the dead person. And it suggests that they had a belief. It suggests that there's some sort of belief surrounding. We can't say what it is, but it suggests that they may be believed in afterlife or something like that. They certainly attached, when a person died, they certainly attached importance to them, sufficient that they tried to let their burial reflect some sort of comfort. And they put them into the child's position, or the sleeping position, put flowers on them, and things like that. Now, Homo Neanderthalensis was a successful species, but it existed at the same time as another species. And that species was Homo sapiens. They had undoubtedly arisen from a common ancestor, but there were these two lines, the Neanderthal line and the Sapiens line. And there is some considerable evidence that, in fact, the two species interbred. There are places, for example, there are caves where a number of Neanderthal and Homo sapiens skeletons have been found, where there is intergradation, which suggests that there was hybridization between the two. Many people think that Neanderthals should in fact be called Homo sapiens, but that they were a subspecies, Homo sapiens neanderthalensis. The genetics certainly bears that out. When we look even at our own genome, it appears that our genome, some people ascribe certain genes to the Neanderthals. We have been able to extract Neanderthal DNA from Neanderthal skeletons and sequence it. And it seems that some of that DNA, some of the genes appear in some human beings in their genome, especially people from the southern Mediterranean appear to have often some genes which may have been derived from Neanderthals, which is very interesting. I would love to be able to say that I have Neanderthal genes because I think that they were a remarkable species. Here they are here. If you looked at if you saw Neanderthal walking down the road, you wouldn't necessarily think very much about it, excepting that they have a rather heavy brow ridge, but a prominent nasal bridge. The only thing about them is they have a relatively weak chin. The chin is not very prominent, which is very distinctive for Homo sapiens. But other than that, you wouldn't really think much about it. The one thing I will point out, though, is have a look at the shape of the eye sockets. The eye sockets are round. Now, here's another human feature. Human eye sockets are rectangular. Homo Neanderthalensis, they are round. They were extremely muscular. They were big, robust beasts with heavy muscles, extensive cultural interaction between them. And we even see there are even suggestions of fights or battles between different tribal groups of Neanderthals. But if you would see them, you would recognize them as being human. The only thing about it would be there'd be a certain primitive look to the skull, simply implied by heavy brow ridges and the fact that there is no strong chin. But other than that, there's very little to distinguish them from human beings. Again, extensive culture. They cared for their old and for the sick and for the disabled. They buried their dead with ritual. And so this is a very refined species. They were also able to survive under very, very harsh, adverse conditions. They lived in Europe as the Ice Age was advancing. That may well have contributed to their demise, the ultimate demise. But this was an intelligent, skilled species. They disappear about 50,000 years ago. Exactly why, we don't know. They coexisted with Homo sapiens, which was very successful as well. And the Homo sapiens that existed at the same time we call Cro-Magnon man. And we'll see him in a while. And Cro-Magnon appears to have been much more successful at living through these very harsh climatic conditions. You may well ask, why didn't the species simply migrate back into Africa? They didn't, because there was extremely rich Homo sapiens culture in Africa already. And the Neanderthal man couldn't move it somewhere where another species was very successful. So they were sandwiched into this Europe and Asia. And they died out about 50,000 years ago, unfortunately. But here you can see, I told you they folded up they're dead into fetal position. Here they are here. Here a group all died and were buried together. And they did it carefully. And we have evidence that they put flowers and branches and things over the dead. So here's our own species now. This is Homo sapiens. And Homo sapiens appears in Africa about 200,000 years ago. So you'll realize that it coexisted with other species, and especially with Neanderthal. The other species of Homo that were coexisted died out for reasons that are not clear to us. But it may well have been because Homo sapiens was so successful. The species arose in Africa, and we can truly say we are all African, because other species of Homo which existed outside of Africa all died out and left the Homo sapiens, whose original ancestor was in Africa. Here's a very primitive human. This is still Homo sapiens, but a very early skull. And you can see it preserves some primitive features. Heavy brow ridge. The skull overall is heavy, but it has a prominent nasal bridge. The jaws have a prominent chin. And look at the shape of the eye socket. The eye socket now is becoming square, which is a very, very sapiens character. Here you can see, look here, there, you can see prominent nasal bridge, square eye sockets, and now look here, this distinct chin. That makes this Homo sapiens. And it's properly Homo sapiens sapiens, if we want to be particular about it. And we have the largest brain of all of brain case of all of the hominins. It is true that Neanderthal, some of the Neanderthal skulls have a larger brain than some human do. But the median for humans is higher even than Neanderthal. We overlap with Neanderthals, in other words. It'd be very difficult to tell the difference between a Neanderthal brain and a human brain. Now this skull here is from this group called the Cro-Magnons, who coexisted with the Neanderthals for a time and then overtook them. So these are the Cro-Magnon is really the early European man. Homo sapiens arose in Africa and then migrated out of Africa and migrated very widely. Their initial entry into Europe founded this civilization called the Cro-Magnon. And they were early Homo sapiens. But after that, human beings, of course, traveled extremely widely, extremely widely, and populated all of the continents except for Antarctica, which they could neither get to nor have survived in. But all of the other continents were colonized by Homo sapiens. We are one of the most successful of all living species. We are extremely numerous, as you know. We have penetrated into virtually every climatic region of the globe. We're able to survive the most extraordinary circumstances, desert, ice, whatever. And we do so because of our ability to manipulate our environment around us. We create an environment around us, merely wearing clothes, living in shelter that we build, using fire. All of these things enabled man to carry a suitable environment, a livable environment with them into virtually any part of the globe. Very often, these migrations were driven by competition. Cro-Magnon, for example, was so successful in Europe. They were extremely numerous, and they used up a lot of the resources. And groups of Cro-Magnon were driven out by necessity, by need, to start migrating, to go and find places where they could get the resources that they needed. Okay, but here is one of the most important, in my opinion, one of the most important aspects of what makes us human, and that is our artistic ability. Now, this here is from South Africa. Now, this is the very earliest example of an artistic, abstract artifact. And this is just a little block of soft stone in which somebody has carved these lines. But this and it's very, to our eye, very simple. But if you look at it, you'll realize that these are very deliberately carved. And there's been an attempt to create a design, a particular design on this. And this is 77,000 years old. And this is an example of the fact that really art is one of the hallmarks of modern man. Because if you look at this, you have to ask yourself, why was this done? Why? Did it have any use? No, it didn't have any use, really, except the use that the person who made it attached to it. And that probably was that it was aesthetically pleasing. It was an expression of creative ability, whatever. And later on, more advanced art might acquire magical, symbolic meaning. And it became a very important aspect of human culture, especially amongst groups like Cro-Magnon. First of all, the tools that they made were extremely refined. They were made with an idea about the aesthetic of the tool. But associated with Cro-Magnon as well are these extremely beautiful cave paintings. These cave drawings evidently had magical, symbolic meaning to them. But you can see here, this is truly modern man. This is Homo sapiens. And one of the things that really distinguish us, not only from all other animals, but from our other close relatives like Homo erectus. These are cave paintings from Europe. And these, are in our eyes, extremely old, 20,000, 30,000 years old, whatever. But in terms of the whole span of human evolution, of course, these are relatively recent. The people who made these are very, very close to us in every way. They're very close to us genetically, and the culture that they laid down is inherited by us in many ways. One of the things, these are 32,000 years old, these little statues. And you can see now the symbolic representation of the people themselves and of the animals around them now being created, not only put in 2 dimensions onto the walls, but created as 3-dimensional, probably magical objects, and associated with creation of something that looked like something was associated the spiritual or magical properties that they associated with what they were representing. So now we arrive now at us, at Homo sapiens, us ourselves sitting here looking at our computers, these absolutely extraordinary tools that we have made. And we have to try and place ourselves on this planet. And all of the changes which have led up to us have been driven by natural selection. Our species has been created by a continual dance and interaction with our environment and with the other species that existed around us. But man is different to other species. And we are different in that we alter our environment extensively, not only to serve ourselves. We change our environment, for instance, to grow food, to raise animals, to raise food crops, etc. But we have begun to change the very nature of our planet. Our very success may, in fact, be our downfall. We have become one of the most numerous of all of animal species. And our ability to continue as a species may be threatened by our very success, because we are beginning to change our environment in ways which are very, very dangerous and very damaging. In fact, in fact, geologists now are labeling our current era the Anthropocene, the era of man, because we are beginning to change the world so significantly that it is going to be reflected in the geological record, which is an extraordinary thing to think about. And as we finish this class on human biology, we have to ask ourselves the question whether our success is now threatening our ability to proceed as a species. We are the very last member of our species. We're currently the last member of our species, of our genus rather, of Homo sapiens. We are the only members of the genus Homo left. Will we in time evolve to other species to respond to these changes in our environment? We cannot say. But we need to ask ourselves the question about whether or not at this stage of this huge success of human beings, we don't bear some responsibility to try to maintain this planet which has produced us. So with that slightly philosophical thought, I'll leave you there. I hope that you've learned something in this course. And I remind you, please, that your final test is on Friday. Okay, it's not on Wednesday. Your final test is on Friday at 10 o'clock. Study guides have been put up for all of the sections, and I've enjoyed teaching you, and I wish you all well.